Okay guys, this is the second half of the 5.4 notes, day 3. So we're continuing on with the same directions as I had in video 1, where you need to solve each equation over the domain of 0 to 2 pi. 0 included, 2 pi not included, and make sure that you're giving your answer in radians and that you are providing a diagram. Okay. Go ahead and copy this example. So this would be example 4. Okay. Now, if you look at the left side of this equation, you should notice that you have two linear terms. However, there's two different functions. There's cosine and sine. So that would be like trying to solve this equation. You can't because there's two different variables. Now with just x's and y's, there's nothing you can do to solve this. You would need to have another equation with x's and y's and solve it with like a system of equations. So this one you wouldn't be able to do, but this one on the left you can, because there is a relationship between sine and cosine squared, sine squared and cosine squared, according to the Pythagorean identity. Do you remember that cosine squared plus sine squared theta, or x, equals 1? So you are allowed to rewrite either one of these trig functions to either all sines or all cosines. Now, my brain just went to changing the cosine, but really you could also change the sign in terms of cosine. Option is yours. I'm going to go ahead and change this guy. So cosine squared of x is the same as, so cosine squared of x equals 1 minus sine squared of x. So I'm going to go ahead and replace that with 1 minus sine squared of x, and then bring down the negative 3 sine squared of x. So again, I couldn't solve this equation before because I had two different trig functions. We practiced this skill when we first started section 5.4 of how to rewrite a quadratic using just one trig function versus two. All right, so I'm going to now go ahead and combine like terms. So negative 1 sine squared x minus 3 sine squared x is negative 4 sine squared x. Bring down the 1. And then this is a quadratic with no linear terms, so I can use StatMap. It is also a difference of squares, so you can factor it, but I'm going to go ahead and use StatMap. Again, if it's a difference of squares, you can always factor it, which this is. So now, since I'm using StatMap, my goal is to isolate the trig function and get rid of the exponent. So now I'm going to square root both sides. Remember that when you square root a fraction, you have to square root the numerator and the denominator. If it doesn't come out perfectly, here it did. Square root of 4 is just 2. But if I would have gotten something like 1 over root 3, I'd have to rationalize it. And I showed that in the previous video. So I am looking for x. I'm solving for x. So I'm trying to find out the sine of what angle is positive or negative 1/2. The sine of what angle is positive or negative 1/2. So sine is the y value. So if you're thinking quadrants, right? Cosine is positive in quadrants 1 and 2, and sine is negative in quadrants 3 and 4. So we're actually looking for angles in every quadrant. Now think of your special triangles. This would be opposite over hypotenuse. Which reference angle would allow you to get 1/2 if you use opposite over hypotenuse? Would it be a 30, 60, 90? Would it be one of those angles, or would it be a 45, 45, 90? Which of those would give you 1/2 if you use a reference angle? I'm going to fill in my sides. And opposite over hypotenuse looks like it's going to be pi over 6 as my reference angle. So since I'm looking at all 4 quadrants and I have a reference angle of pi over 6, I need to find all of these. So this is 1 pi over 6. This is 1 pi over 6 away from from 1 pi. So this would be 6 pi over 6. This would be 0, aka 12 pi over 6, the full rotation. So this would be 5 pi over 6. 1 pi over 6 past 6 pi over 6 would be 7 pi over 6. And 1 pi over 6 before reaching 12 pi over 6 would be 11 pi over 6. So remember, the question was asking you the sine of what angle is going to be positive 1/2 or negative 1/2. The sine of any of those angles given in red, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are all the solutions. Now, if you have a calculator, you can go ahead and check your answers. Make sure you are in radian mode. Take the sine of pi over 6. Take the sine of 5 pi over 6, etc. And if they're all giving you positive 1/2 or negative 1/2, then that's great, because that's what the question was asking. Sine of what angle? Sine of what angle is positive 1/2 or negative 1/2? So if you see a problem like this one, where they gave us 2 trig functions, you can rewrite either one of them so that you have a problem with only one trig function. Okay, when you're ready for example 5, make sure you write it down. Okay, for the first time we have a quadratic trinomial. There is a linear term. This is similar to 2x squared minus 5x plus 2. Because it's a quadratic trinomial, you have to factor it. So we need to find 2 numbers that multiply to positive 4 but add to negative 5. Now remember, all of you guys factor differently, or there's many different ways to factor. So use the strategy that you feel the most comfortable with to factor that. Go ahead and pause the video. When you're done factoring it, unpause the video to check your answer. Okay, you should have gotten x minus 2 and 2x minus 1. Some of you guys factored incorrectly on the quiz that you guys turned in to me because you didn't FOIL or distribute your 2 binomials. Remember, when you distribute these and multiply them out and combine like terms, you should get the original trinomial that you started with. So you can always check your factoring by multiplying it out. Okay, so I'm going to go ahead and relate this answer back to the original problem that had trig functions. So instead of x, I'm going to use cosine. So this factors to 2 cosine of x minus 2, and cosine of x minus 2, and 2 cosine of x minus 1. So again, the x's in your binomials are your cosines. whenever you have a binomial that is set, or sorry, a quadratic trinomial that's set equal to 0, factoring is not the final step. So think back over here. This quadratic trinomial was originally set equal to 0. So some of you already know what to do next. You set each factor equal to 0 and solve each one individually. So the answer would be 2, and the answer would be 1/2. So that's what we're going to do over here. We're going to set each of these binomials equal to 0 and solve each one. Okay, so we've got a linear term and subtraction. I'm going to go ahead and solve these by isolating my trig function. They're not quadratic, so I'm just going to use StatMap. You get cosine of x equals 2. And then on this side, I'm going to cancel it. Remember, I'm using StatMap. If you feel like I'm going too fast, make sure that you take my advice where you just listen to the problem the first time that I do it, and then rewatch the video and write the steps. Because if you're trying to do the problem at the same time I am, you might get behind and you might miss out on explanations. Okay, we're almost done. Cosine of what angle would be 2? Think of your special triangles. Whoopsies. Remember, cosine is opposite over, adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse. Okay, which of these reference angles, pi over 6, pi over 3, or pi over 4, would give me adjacent over hypotenuse of 2? Think about it. Would it be pi over 6, adjacent over hypotenuse? Nope. Would it be pi over 3, adjacent over hypotenuse? Nope, that would give me a 1/2. What about pi over 4, adjacent over hypotenuse? That'd be 1 over root 2. So none of these work. What about your quadrantal angles? Remember, cosine is the x value. Do any of your quadrantal angles have an x value of 2? Remember, cosine is an x value. None of these have a 2. So this is not possible. This is called an extraneous solution. It means that we solved the problem correctly, we factored it correctly, but none of the triangles or quadrantal angles would give me a cosine that equals 2. All right, now let's see if any of these angles as a reference angle can give me 1/2 if I use the cosine. So let's start with pi over 6. Adjacent over hypotenuse? Nope. What about pi over 3? Adjacent over hypotenuse? Yep. That would be pi over 3. So your reference angle for this guy is pi over 3. Now notice, cosine is an x value. So we need it to be positive 1/2. X is only positive in quadrants 1 and 4. So I want a reference angle of pi over 3. Okay. So this one would be 1 pi over 3. 2 pi over 3 would be here. 3 pi over 3, aka 1 pi, would be here. This would be 4 pi over 3. That would make this 5 pi over 3. So your two solutions are pi over 3 and 5 pi over 3. So again, they were asking cosine of what angle is positive a half? My answers are that x can be pi over 3 and or 5 pi over 3. Remember that you can check your answers if you're in radian mode. Take the cosine of pi over 3, you should get a half. Take the cosine of 5 pi over 3, you should also get a half. If you still have questions, make sure you send me a message. Have a good day, guys. Bye.